Hello. This presentation concerns a paper elevating everyday voices and people in archives through the application of graph database technology. My name is Mark Conrad, and my co-author and co-presenter is Dr. Lenice Williams. Unfortunately, due to technical difficulties, we were not able to record Lenice's remarks directly, and so when we get to the points in the presentation where she should be speaking, I'll be reading her written remarks. So a little bit of background. Lenice and I are working on a project currently where we have a large volume of records in analog form, some of which are being digitized, and we're trying to figure out ways to make those records more discoverable by increasing the number of access points to that collection for use over the internet. There are a number of challenges with searching archival materials over the internet. First of all, archives often have millions or billions of records, and many, in most cases, most are in an analog form. They're paper, they're photographs, they're other hard copy materials that are not available over the internet. And those materials are often described in the aggregate rather than at the item level. So you'll have descriptions of entire collections and or record series within those collections, but you won't have descriptions of the individual items in each collection. In most cases, it's simply because there are too many of them, and archival descriptive practice up until now has been to make those descriptions by hand, and so to make them at the item level, where you have millions or billions, would take decades or centuries to complete all the descriptions for your entire collection. So user expectations for searching archival materials are often not met, and it's because they're used to a world where you enter a few words into a search engine and the materials appear on the screen. Well, for the reasons I've already listed, that's very rarely possible. Another thing to note is that consumers are unaware or choose to ignore that the search results they get aren't comprehensive, because they don't usually cover all the analog material that's out there that might be relevant to their search, and they're not representative. They're the biases of the people who enter the search terms or do the indexing mean that underrepresented communities are less likely to be found in search results. I would commend to your reading list Algorithms of Oppression: How Search Engines Reinforce Racism by Sophia Noble as a good source to read more about this. So Lenice and I decided we would do a little initial experiment just to see if we could figure out a way to increase the number of access points at the item level and to increase the representation of underrepresented voices in the collections. So, how do we increase the number of access points to items in the collection? Well, we decided we would use existing tools. In this case, we used graph database, a text editor, a few spreadsheets and Word documents, and we used existing machine-readable data. We used Born Digital items and Born Digital finding aids, and our primary idea was that we would use the graph database to connect people, places, and events across the individual parts of the collections. What we're doing here, this experiment, is not something that's new. Others have used graph databases with archival collections. The European Holocaust Research Infrastructure has been using graph databases for, I think, over a decade. And SNAC, the Social Networks and Archival Context, is also using graph databases to make connections to people across collections. But these efforts and most previous efforts using graph databases with archival collections have been done at an aggregate level, at the collection or series level. So they're not saying, if you're looking for John Doe, we're going to take you to all the documents that refer to John Doe. We're going to take you to collections where you might find those documents. Linus writes, let's look at some of the representational and ethical implications of the decision points. The conversion of analog materials to machine-readable and searchable forms is challenging and often much more complex than what's usually discussed. Oftentimes, guidelines for conversion emphasize technical specifications with little consideration for how those specs impact who the analog materials represent or who is imaged in there. Conversion technologies like microfilm and digitized microfilm, this is the technology that has been used on most pre-2006 archived newspapers, have racial implications. Microfilm has inherent qualities that make it unsuitable for representing some groups but not others. It's made to record extremely dark and extremely light tones, most suitable for recording text. Skin tones of most people of color fall in between those two tones and into the dark tones. Linus continues, here's what that looks like. Here's one newspaper image displayed two different ways. On the left, what we see is what you see when using an archival digital database, a physical copy that has been microfilmed and then digitized. On the right is a high-resolution image of the physical copy. The left image, with the widest circulation, since it exists in a digital archive, has been transformed through two conversion technologies, microfilm and low-resolution digitizing. The damage to the image of the black boxer is clear. All subtleties in his skin tone and facial contours is minimized and erased. Half of his face is rendered pitch black, very far from how it actually appears on the physical copy. Photographic representations of people of color in pre-2006 newspaper archives range from distorted, minimized, to erased because of microfilm's inherent qualities, which are compounded by digitization. People of color, marginalized in U.S. society, are erased from the historical record. Who is represented is inextricably tied to decisions about the transformation technology and the aesthetics of representation, or how they are represented. This kind of systemic racism and unconscious or unexamined racial presuppositions shape historical memory. Specialists like art historians versed in a deep understanding of representation and conversion technologies are much needed, invaluable contributors to this decision-making process. So given what we knew about the collections, what we knew about the impact that technical decisions can have on the representation in collections and on the limitations of traditional finding aids to meet the expectations of the users, we decided to conduct a short experiment. This was a very low resource. What can we do with the low-hanging fruit to see if we could increase both the number of access points at the item level and the representation level of the descriptions of the entire collection. So what did we do? Well, we leveraged several existing finding aids. There was an index to correspondence. It was a Word document. There was a spreadsheet that contained an index to photos. There was the descriptive information in the project's primary descriptive catalog. So we use these three things to take a look. We took the index to correspondence, which was a Word document, using BBEdit as a text editor, created an CSV file of that had the from, the subject, the date of each piece of correspondence in the index, and also the collection, the series, the folder, and the box. The box and the folder where that particular item was located. We took the spreadsheet containing an index to photos, which had a list of who was in the photos. Well, basically the caption for the photo. We extracted the names of the people that were identified, the location if we could determine it, the date the photo was taken if we knew it, and then again the information about where in the collections each photo was located. So we've now got two CSV files. We looked across them and we saw that names were represented in different ways. So you'd have one name that said Ms. Williams, so you'd have another one that said Dr. Williams, and you'd have another one that would say Lanice Williams. So we wanted to figure out if there was an authoritative list of names. So we went into the descriptions from the descriptive catalog. They were exported from the catalog in XML. We were able to isolate the lines that had authoritative names, and unfortunately the list of authoritative names wasn't very long, and in some cases we still couldn't identify what the authoritative name should be. But in those cases where we could, we updated the CSV files so that we had a single name to represent all the items that we knew belonged to a particular person, or recorded information about a particular person. So we loaded the CSV files into a graph database, and once we had them in there, we ran a couple of queries and created visualizations that display related records across collections. So if you've got an item in multiple collections that has information about Lanice Williams, for example, it shows you those items and relates them to Lanice so that you can find them across the collections. We also displayed relationships between person, places, and events that are described in the collections. So here's an example of a simple query and a simple visualization from the data in the graph database. By the way, all the names and the descriptions in this visualization have been fictionalized, have been anonymized, because the collections we were working with are not yet fully processed and are not yet available to the public. So anyway, what are we seeing in this image here? So you've got orange circles, and they represent people. You've got green circles that represent letters found throughout the collections, and with the subject of the letter in there. And then there's a blue circle which represents a photograph, and it has the caption from the photograph. And between all the circles you see arrows of various colors, and they're pointed in one direction. So if you start over on the left side, you see that Greg Jansen sent a letter concerning travel to Lanice Williams. Lanice received the letter. From Lanice's circle, you see that she appears in the photograph, and then if you look in the circle, it has the caption from that photograph, and we see that two other people also appear in that photograph. The letters, the green circles, come from across multiple collections, and if you click on one of them, you can see the information about where that particular piece of correspondence can be located, what series it's in, what box it's in, what folder it's in, so that you could quickly find all the correspondence that was either sent or received by one of the people in the visualization. So this was a simple experiment, and the results weren't stellar, but they're promising. We see that graph database technology could be useful in increasing the number of access points, and also increasing the representation of underrepresented people, places, and things in the collections. For the future, we hope to use tools like named entity recognition to look for names of persons, places, and things in machine-readable texts that aren't normally indexed. You know, when an archival repository is describing records, they'll often talk about, or they'll have index entries to the Abraham Lincolns and the George Washingtons in their collections, and not so much the Joe Smiths and the Mary Jones. So we hope to use those kinds of tools to find more names in the individual documents and to be able to add that to the graph database. We also are going to look at entity recognition tools to examine digital photographs to look for persons and cultural items in the photographs that aren't identified in the descriptions for those. And we'll continue to document ethical and representational implications of the decisions that are made about technologies to use in providing online access to archival materials. And as we've emphasized throughout our paper and this presentation, technology, especially the decisions that humans make about how to apply that technology, is not neutral. When you're making decisions about applying technology to archival collections, you're making decisions that may impact the historical record. All right, well, thank you very much for your attention, and I guess we'll have questions in just a minute.